Hello friends, welcome back to my channel Maths by Samit Deshmukh. In this video, we are first discussing what is the meaning of implicit function, and later on we will see how to find out its differentiation. Now consider here one function. So we have considered one function, say y is equal to x cube plus 10x square minus 5x plus 3. If you observe this function very carefully, here value of y is entirely expressed in terms of what? X. Means value of y is entirely in terms of which variable? X. That's why we can say that x is independent variable and y is dependent variable. That part already we have discussed when we have discussed the definition of differentiation. Here just observe that value of y is entirely expressed in terms of what? X. In such cases we say that y is expressed explicitly as a function of x. Means y is expressed explicitly, means entirely in terms of x, and such functions are called as explicit function of x. Means here we can say that y is an explicit function of x. Means when value of y is entirely expressed in terms of x, at that time function is called as what? Explicit function. Now consider another example. In this case, what is the function here? X square plus 3xy minus 2y square is equal to 0. Or consider another example, tan xy plus x square y is equal to y. Means in both the example we can observe that value of y is not entirely expressed in terms of what? X. So in such cases we can say that it is nothing but relation that does not give y explicitly in terms of x. However, each of these equations defines a relation between x and y. Means these functions defines a relation between x and y. In such cases we can say that either of the variable is an implicit function of each other, and such functions are called as what? Implicit function. Means both the variables are implicit function of each other, or in other word we can say that such functions are called as implicit function. And we are discussing here differentiation of implicit function. Means simply you have to remember that when value of y is not entirely expressed in terms of x, at that time function is what? Implicit function. Now observe how to find out differentiation of implicit function. Here we have considered example number first from question number 3 from exercise 1.3. Here one function is given to us, root x plus root y plus root a, and we have to differentiate it with respect to x, and here we can observe that value of y is not entirely expressed in terms of x. Means we can say that it is implicit function. And now whatever may be the method we are using in first example to find out the differentiation, same method we are applying in every example. So whatever may be the function is given to us, differentiate it, whatever may be the functions is given as is stand, whatever may be the function is there, our aim is to differentiate it. So now what is differentiation of root x? Derivative of root x is equals to 1 upon 2 root x plus, now instead of x, if another term appears, at that time we can say we will consider it as what? F of x. Means ये function कौन से form में है? root f of x. और root f of x का differentiation क्या है? 1 upon 2 root f of x. What is f of x here? Y into its derivative, means into derivative of y, means dy by dx. So in this way we have got differentiation of this term. On this side, derivative of root a will be equals to 0 because variable does not appear. Means we can consider it as constant term, and we know that derivative of constant term is 0. Now differentiation is completed. Remaining part is just simplification part. So here collect the term of dy by dx on one side. Only one term of dy by dx is there. So collect this term on one side. So 1 upon 2 root y dy by dx, and collect all remaining terms on another side. But as is stand here only one term is there, so we are collecting this term on this side. So 1 upon 2 root x, so plus 1 upon 2 root x on this side will become minus 1 upon 2 root x. So therefore dy upon dx is equals to, see our aim is to find out value of dy by dx. इसका मतलब ये साइड में सिर्फ dy by dx के टर्म होने चाहिए, बाकी के सब टर्म हमें दूसरी साइड में ट्रांसफॉर्म करने हैं यूजिंग द रूल्स ऑफ ट्रांसफॉर्मेशन. सो ऑन दिस साइड -1 upon 2 root x, keep it as it is. Here we can observe that what is denominator 2 root y. So on this side it will be divided, तो ये side में क्या हो जाएगा, multiply हो जाएगा 2 root y. So 2 root y will get multiplied on this side. So therefore dy by dx will be equals to, so minus keep it as it is. Here we can observe that 2 and 2 will get cancelled, and minus we have already kept as it is. Now observe the remaining term, root y divided by root x can be written as under root y by x, because we know that root a upon root b can be written as under root a upon b using laws of surds. And these laws of surds we have already studied in your earlier classes, which has been proved using laws of exponent or laws of indices. So root a upon root b means root y upon root x can be written as under root y by x, which is nothing but our required differentiation. What we have seen here, जो भी फंक्शन दिया है एज ए स्टैंड जैसे भी है उसे डिफरेंशिएट करना है. फिर क्या करना है, एक साइड में dy by dx के टर्म कलेक्ट करना है और बाकी के पूरे टर्म अदर साइड में कलेक्ट करना है. फिर इधर dy by dx का जो भी कोएफिशिएंट है वो भी इधर ट्रांसफॉर्म करना है यूजिंग रूल्स ऑफ ट्रांसफॉर्मेशन. रूल्स ऑफ ट्रांसफॉर्मेशन सेज दैट प्लस है तो इधर माइनस होगा, माइनस है तो प्लस होगा, मल्टीप्लाई तो डिवाइडेड होगा और डिवाइडेड है तो मल्टीप्लाई होगा. सो यूजिंग रूल्स ऑफ ट्रांसफॉर्मेशन ट्रांसफर all the terms on another side, then simplify this side, and whatever will be the simplest form we are getting will be our required value of dy by dx. Now observe the second example. Here also this is an example of implicit function. All the example from this question number 3 are the example of implicit function. So first we are trying to simplify this given function, and later on we will differentiate it. So here x, keep it as it is. Can I write root x as x raised to power 1 by 2? Yes. Plus y, keep it as it is. Root y can be written as y raised to power 1 by 2. A, keep it as it is. Root a can be written as a raised to power 1 by 2. Now here we can observe that the base are same. Then according to laws of exponent, if base are same, then we are taking addition of power. What is power of x here? 1. And 1 plus 1 by 2 will be equal to 3 by 2. Means what we are getting here, x raised to power 3 by 2. Here also base are same, so take the addition of power. Here power is 1. 1 plus 1 by 2 will be equal to 3 by 2. In this same way, here also we will get a raised to power 3 by 2. Now we are differentiating it with respect to x. Differentiate it with respect to x. So this term is in the form of x raised to power n. So our formula says that first take power of x as an coefficient and decrease power by 1. So 3 by 2 minus 1 will be equal to 1 by 2. Plus here also take power of y as an coefficient, then decrease its power by 1. So new power will be 1 by 2 into derivative of y is dy by dx. And if you observe this side, term of variable does not appear, means we can say that it is a constant function, and we know that differentiation of constant function will be equal to 0. Now differentiation is completed. Now on one side collect the term of dy by dx. Only one term of dy by dx is there, that is 3 by 2 into y raised to power 1 by 2 into dy by dx, and this plus term on this side will become minus 3 by 2 x raised to power 1 by 2. So here easily we can observe that 3 by 2 and 3 by 2 on both side will get cancelled. On this side remaining term is y raised to power 1 by 2 into dy by dx, and on this side minus, after cancelling 3 by 2 on both side, here remaining term is x raised to power 1 by 2. So dy upon dx will be equals to minus x raised to power 1 by 2, keep it as it is, in the denominator y raised to power 1 by 2, because this term is multiplied. On this side it will get divided, isn't it? Now differentiation means value of dy by dx is known to us. Let us try to write down this value in the simplest form. So which is equal to minus, keep it as it is, x raised to power 1 by 2 means it is root, it can be written as root x. In the same way y raised to power 1 by 2 can be written as root y. So which implies that dy upon dx will be equals to minus, keep it as it is, again according to laws of surds, root a upon root b can be written as root a upon b, means root x upon root y can be written as under root xy, which is nothing but differentiation of this given function. Now see in the third example, given function is x plus under root xy plus y is equals to 1. So let us differentiate it with respect to x. What is derivative of x? Derivative of x with respect to x is 1. plus here if you'll observe the function, it is in the form of under root f of x, and we know that derivative of under root f of x is 1 upon 2 root f of x. What is f of x here? X into y into derivative of f of x, where f of x is nothing but what? Xy. So, plus now we are differentiating y. We know that derivative of y with respect to x is dy by dx, and on this side derivative of constant term, one is a constant term, that's why we can say that its derivative is 0. So now here again we have to differentiate this term. So 1 keep it as it is, plus 1 upon 2 root xy also as it is. We are differentiating it, but if you observe this function, it is in the form of what? Product of two function, means it is in the form of u into v, and to find out this differentiation we have to apply product rule. According to product rule, keep first term means x as it is into derivative of second term, means second term is y, so derivative of y is denoted by dy by dx plus second term as it is into derivative of first term, means derivative of x will be equals to what? 1. So in this way we have got the differentiation of this term. Keep this last term dy upon dx, and on this side is equal to 0, keep it as it is. In this way differentiation is completed, but question is to find out dy by dx, simplifying this expression. So here we are simplifying, keep 1 as it is. Now we are multiplying by 1 upon 2 root xy to both the term in this bracket. If I am multiplying to first term, what will get here? X into 1 will be equal to x upon 2 root xy and dy by dx. Just I am multiplying by 1 upon 2 root xy to first term. Now I am multiplying to second term. See what will get? Y into 1 will be equal to y upon 2 root xy plus dy upon dx is equal to 0. Keep it as it is. Now on one side we are collecting the terms of dy by dx and remaining terms on another side. But before that, let us check, is it possible to simplify it? Yes, we are able to simplify it. Observe the simplification part. Here x divided by root x. Here root xy can be written as root x into root y. So here division of x and this root x will be root x. We know that x upon root x will be root x. In the denominator 2 root y, because root x will get cancelled with 1 root x in the numerator. X can be considered as what? Square of root x. So 1 root x will get cancelled. So here remaining term is root x. Keep this dy by dx, keep it as it is. Here also same method we are applying. Here y divided by root y will be root y. And in the denominator remaining term is 2 root x, because root y and 1 root y from numerator will get cancelled, because y can be written as what? Square of root y. Again square and root will get cancelled, will get y. ये y बोले तो क्या है? Square of root y. तो ये root y और एक root y cancel हो गया square में से. So what is remaining term? Root y. Hope you have got the calculation part. Plus dy upon dx, keep it as it is. Now on one side we are collecting the terms of dy by dx. How many terms of dy by dx appears? 1, and this one 2. If I am taking dy by dx common from these two terms, let us see what we'll get. Here its coefficient is 1 plus, and here coefficient of dy by dx is root x upon 2 root y. Remaining term we are shifting on this side, so this plus 1 on this side will become minus 1, and this plus term on this side will become minus root y upon 2 root x. Now I am taking cross multiplication here. Let us see what we'll get if we are taking cross multiplication. 2 root y plus root x divided by 2 root y into what? Dy by dx. On this side also I am taking cross multiplication, but parallelly I am taking minus common from both the term. If I am taking minus common, both the term will become positive, and 2 into root x will become 2 root x plus root y plus, because we have taken minus common, and in the denominator we will get 2 root x. Simply we have taken cross multiplication, parallelly we have taken minus also common. Now dy by dx is equals to, so therefore dy upon dx will be equals to, check what is the right hand side, minus 2 root x plus root y divided by 2 root x into, now this term is divided on this side, 2 root y इधर divided है, उधर जाके क्या होगा? Multiply 2 root y, और ये term multiply on that side it will get divided, or means what will get? 2 root y plus root x. Now here we can observe that these 2 will get cancelled. So minus, keep it as it is. In the numerator, root y, keep it as it is, into 2 root x plus root y. And in the denominator, see what we are getting. Here root x, keep it as it is. First write down the term of root x plus then write down the term of what? Root y, means 2 root y. Now nothing is there to simplify, so that's why we can say that this will be the differentiation of this given function. See, in the example number 4, given function is x cube plus x square y plus xy square plus y cube is equal to 81. So we are differentiating this function with respect to x. What is derivative of x cube? First take this power as an coefficient, then decrease power by 1. Here we can observe that product of two function is there. And that's why we have to apply product rule to find out the differentiation. According to product rule, keep first term as it is, means x square as it is, into derivative of second term. Second term is what? Y, means derivative of y is dy by dx, plus second term as it is, y as it is, into derivative of first term. What is first term here? X square. Plus, now to find out differentiation of this term also, we have to apply product rule, since product of two term is there. So first term as it is, into derivative of second term. What is second term here? Y square, plus second term y square as it is, into derivative of first term, means derivative of x, and derivative of y cube. To find out differentiation of y cube, we have to take first power of y as an coefficient, then decrease power of y by 1, then derivative of y is dy by dx, and on this side derivative of constant term will be equal to 0. So here differentiation of all the 4 term we have taken. Only the remaining part is to find out d by dx here, and here also d by dx, and here also d by dx. Wherever differentiation appears, let us try to differentiate it. So here 3x square, keep it as it is, plus here nothing is there to simplify, so keep x square into dy by dx as it is. What is derivative of x square? 2x. 2x into y, it's 2xy, plus here x, keep it as it is. What is derivative of y square? First take power as an coefficient, then decrease power by 1, so new power will be 1, into derivative of y is dy by dx, plus what is derivative of x? 1 into y square, means 1 into y square, plus here 3y square dy by dx, keep it as it is equal to 0 also as it is. Now differentiation is completed. That's why we are collecting the terms of dy by dx. 1, 2, 3 terms of dy by dx are there. If I am taking dy by dx common from these 3 terms, let us see what we'll get. Here its coefficient is x square. Here its coefficient is 2 into xy is 2xy. And lastly, here coefficient of dy by dx is 3y square. Simply we have taken dy by dx common from these 3 terms. So which is equal to, now remaining 3 terms, first, second and this third term, on this side will become minus, means minus 3x square. This plus 2xy will become minus 2xy, and plus y square will become minus y square. So which implies that dy upon dx will be equal to, if you will observe these 3 terms, all the 3 terms contains minus, so that's why I am taking minus common from all the 3 terms. If I am taking minus common, so here we will get 3x square plus 2xy plus y square. Just simply we have taken minus common from these 3 terms, and on this side this is the coefficient of what? Dy by dx. So since this term is multiplied on this side using transformation, on this side it will get what? Divided. So what we are getting in the denominator, x square plus 2xy plus 3y square. Now nothing is there to simplify. That's why we can say that this will be our required differentiation. Now see the example number 5th. In this example, what is the given function? X square into y square minus tan inverse of under root x square plus y square is equal to cot inverse of under root x square plus y square. First we are simplifying this given function, and later on we will differentiate it, because here some possibilities there for simplification. Keep x square into y square as it is. Now on this side, cot inverse of under root x square plus y square, keep it as it is. Now observe that this minus term on this side will become plus, means on this side we will get tan inverse of under root x square plus y square. Just simply this minus term on this side will become what? Plus. Now we have one property that tan inverse of x. So here write down, since tan inverse of x plus cot inverse of x will be equals to what? Pi by 2. So if we are applying this property, let us see what we'll get here. X square into y square on this left hand side, keep it as it is. But if you'll observe the right hand side, check that the terms are exactly in the form of this property. Yes, tan inverse of, consider this whole term as x. Check that same term appears here also, means this term is in the form of tan inverse of x plus cot inverse of x. Then according to this property its value is equal to what? Pi by 2. यहाँ पे जो value है वो अगर यहाँ पे है, then according to this property value is what? Pi by 2. And here we can observe that what is the term here? Under root x square y plus y square, and here also under root x square plus y square. Means we can say that expression is in the form of tan inverse of x plus cot inverse of x. And according to this property its value is equal to what? Pi by 2. So in this way first we have simplified the given function. Now we are differentiating it. So value of this right hand side will be equal to what? Pi by 2. Now we are differentiating it. So differentiate it with respect to x. So differentiate with respect to x. Now to find out differentiation of this left hand side, we have to apply product rule, because product of two term is there. According to product rule, keep first term as it is, derivative of second term means derivative of what? Y square, plus second term means y square as it is into derivative of first term. What is first term here? X square, and on this side derivative of pi by 2 will be equal to 0. In this way differentiation is completed. Now remaining part is simplification part. X square, sorry, here we have to differentiate these two terms also. Just simply we have applied what? Product rule. What is derivative of y square? First take this power of y as an coefficient, then decrease power of y by 1, so new power will be 1, into derivative of y is dy by dx, plus y square as it is, derivative of x square with respect to x will be equal to what? 2x is equal to 0, keep it as it is. So now it can be written as 2x square y dy by dx. Only one term of dy by dx appears, so collect remaining terms on the other side. What is this term? 2x into y square. So plus term on this side will become minus 2x into y square. So which implies that dy upon dx will be equals to, on the right hand side, minus 2x y square, keep it as it is. This term will get divided on this side, means 2x square y. So which implies that dy upon dx will be equals to, now observe here which terms will get cancelled. So here easily we can say that 2 will get cancelled, keep minus as it is. Again if you'll observe it very carefully, x and 1x from the denominator will get cancelled, means what is remaining term in the denominator? X. This x and 1x will get cancelled, and this y and 1y from numerator will get cancelled. So remaining term in numerator is what? Y. So minus y by x will be required differentiation. Now see the example number 6. In this example, what is the given function? X into e raised to power y plus y into e raised to power x is equals to 1. Let us differentiate it with respect to x. Here we can observe that product of two function is there. That's why we have to apply product rule to find out differentiation. According to product rule, keep first term as it is into derivative of second term. What is second term? E raised to power y, plus second term means e raised to power y as it is into derivative of first term. What is first term here? X. Now we are applying product rule to find out differentiation here also, because product of two function is there. Again according to product rule, keep first term as it is, means y as it is, into derivative of second term means derivative of e raised to power x, plus e raised to power x second term as it is into derivative of first term. What is first term here? Y. And on the right hand side, derivative of 1 means derivative of constant term will be equal to 0. Now let us simplify it. X, keep it as it is. Now this function is in the form of e raised to power f of x, because instead of x, if any another term appears, we can consider it as f of x. What is derivative of e raised to power y then? E raised to power y into derivative of y will be dy by dx, plus here e raised to power y, keep it as it is, derivative of x will be equal to 1, plus y as it is, derivative of e raised to power x is e raised to power x. E raised to power x into dy upon dx is equal to 0. Keep it as it is. Here we can observe that two terms of dy by dx are there. So we are taking dy by dx common from these two terms. If we are taking dy by dx common, see what we are getting. Here remaining term is e raised to power x, and here remaining term is x into e raised to power y. Collect remaining terms on this side. So this plus e raised to power y into 1 is e raised to power y, and plus e raised to power y on this side will become minus e raised to power y, and this plus term again on this side will become minus, means y into e raised to power x plus y into e raised to power x on this side will become minus y into e raised to power x. So here our aim is what? To find out dy by dx. So let us try to find out value of dy by dx, which is equal to here minus e raised to power y minus y into e raised to power x. Keep it as it is. This term will get divided on this side, means e raised to power x plus x into e raised to power y. So differentiation is completed, but both the terms in numerator are negative. So better way, take minus common from both the terms. So let us see what we'll get here. Dy upon dx is equal to, if we are taking minus common from the numerator, in the numerator we'll get e raised to power y plus y into e raised to power x, because both the negative term will become positive, and in the denominator e raised to power x plus x into e raised to power y. Keep it as it is. So we can say that this will be the required value of dy by dx. See, in the example number 7th, what is the given function? E raised to power x plus y is equal to cos x minus y. Let us differentiate it with respect to x. If you observe the left hand side, it is in the form of e raised to power f of x. Its differentiation is e raised to power f of x into derivative of f of x. What is f of x? X plus y is equal to, and on this side what is the function? Cos f of x. Cos f of x, so its derivative is minus sin f of x. What is f of x? X minus y into derivative of f of x, means derivative of x minus y. Just we are differentiating both sides by using standard formulas. Now here e raised to power x plus y, keep it as it is. What is the derivative of x? 1, and derivative of y will be equal to dy by dx. On this side minus sin x minus y, keep it as it is. What is derivative of x? 1, and derivative of y is dy upon dx. So here I am multiplying by e raised to power x plus y to both the terms in this bracket. E raised to power x plus y into 1 will be e raised to power x plus y, plus, keep it as it is, e raised to power x plus y into dy by dx is e raised to power x plus y dy by dx. And here also I am multiplying by minus sin x minus y to both the terms in this bracket. Minus into plus will be, minus sin x minus y into 1 is minus sin x minus y, and here minus into minus will become plus, and sin x minus y into dy by dx is sin x minus y into dy by dx. We have to open the bracket so that we are easily able to simplify it. That's why I am multiplying by e raised to power x plus y to both the term in this bracket, and here also we are using same method. Now we are collecting the terms of dy by dx on left hand side and remaining term on right hand side. So let us collect the terms of dy by dx. Now we can observe that this is one term of dy by dx and this is second term of dy by dx. If I am taking dy by dx common here, so here its coefficient is e raised to power x plus y, and this plus term on this side will become what? Minus. So minus sin x minus y, so minus sin x minus y, because that plus term on this side will become minus, and even we have taken dy by dx common from these two terms, means on one side we have collected the terms of dy by dx, collect remaining terms on this side. So this minus sin x minus y, keep it as it is. So e raised to power x plus y on this side will become minus e raised to power x plus y. Just we are using transformation in positive term, on this side will become what? Negative. Now question is to find out dy by dx. So this implies that dy upon dx will be equals to, here easily we can observe that we are able to take minus common from both the term. So what we'll get here, sine x minus y plus e raised to power x plus y. Both the terms are negative. If we are taking minus common, both the terms will become what, positive. और ये term ये side में multiply, इधर आके क्या होंगी, divided होंगी. Means what we are getting in the denominator, e raised to power x plus y minus sine x minus y. In this way differentiation is completed. But if you want to replace this minus, so better way, multiply by minus to both the terms in this denominator. Let us see what we'll get. We are not disturbing to numerator. What is numerator? Sine x minus y plus e raised to power x plus y. And in the denominator, let us see what we'll get. If I am multiplying by this minus to this term, so this negative term will become positive, means we will get sine x minus y, and if I am multiplying to this term, here we will get minus e raised to power x plus y. Just simply I am multiplying by minus to both the terms here. In this way we have got the value of dy by dx. Now see the example number 8. Here given function is cos xy is equal to x plus y. So let us differentiate it with respect to x. So what is derivative of cos f of x will be equal to minus sine f of x, here f of x is x into y, into derivative of f of x. F of x is what? X into y. On this side, apply addition rule to find out differentiation. First find out derivative of x. Derivative of x is 1 and derivative of y with respect to x is dy upon dx. Now on the left hand side, minus sine xy, keep it as it is. Now to find out differentiation of this term, we have to apply product rule, because product of two function is there. First function is x and second function is what? Y. According to product rule, keep first term as it is into derivative of second term is derivative of y, plus second term as it is into derivative of first term. First term is what? X. On this side 1 plus dy upon dx, keep it as it is. Now I am multiplying by minus sine xy to both the terms in this bracket. Let us see what we are getting here. Minus sine xy into x dy by dx is minus x sine xy. X into minus sine xy is minus x sine xy into dy by dx. Now what is derivative of x? 1. 1 into y is y, and if I am multiplying by y, here we will get minus y sine xy, and on this side 1 plus dy upon dx, keep it as it is. Now we can observe that differentiation is completed. On the left hand side we are collecting the terms of dy by dx, and on right hand side collect remaining another terms. So here keep this term of dy by dx as it is, minus sine x y, keep it as it is. So this term on this side will become minus. So we are just simply taking dy by dx common from two terms. How many terms of dy by dx are there? 1, 2. This plus term on this side will become minus, and if we are taking dy by dx common, so here remaining term is minus 1, because its coefficient is plus 1. On this side it will become minus 1 after taking dy by dx common from both the term. Now on this side keep this 1 as it is, and this minus term will become plus y sine xy, isn't it? So now if we are taking minus common from both the term, let us see what we'll get. This minus 1 will become plus 1, and this negative term also will become plus x sine xy. Just simply we have taken minus common from both the term. Here dy upon dx, keep it as it is, and on this side also 1 plus y sine xy, keep it as it is. So this implies that dy upon dx will be equals to, now in the numerator 1 plus y sine x into y, keep it as it is. So now here this negative term I am shifting on this side, so here we will get minus, and this term is multiplied on this side, it will become divided 1 plus x sine xy. In this way we have got the differentiation of this given function. Now see the last example from this question. E raised to power x minus y is equal to x by y. So easily we are able to simplify it applying, or by applying logarithmic differentiation method, means taking log on both sides. If we are taking log on left hand side, so what we'll get here, log of e raised to power x minus y, and on this side we will get log of x upon y. Just we are taking log on both sides. Now according to laws of logarithm, this power can be taken as coefficient, means e raised to power x minus y we have taken as an coefficient into what, log e, and on this side log a x upon y can be written as log x minus log y. Just we are applying laws of logarithm. We know that value of log e is equal to 1. So 1 into e raised to power x minus y is e raised to power x minus y, and on this side log x minus log y. Keep it as it is here, give the reason, since value of log e is equal to 1, because here nothing is in the base, means e is there, and we know that any number, log of any number to the same base is always equals to what, 1, according to laws of logarithm. So not necessary to write e here, because in calculus we are studying about what, natural logarithm. Nothing is there in the base, means it is considerable that e is the base of logarithm. Well, now we are differentiating it with respect to x. Differentiate with respect to x. On this side, function is in the form of e raised to power f of x. So its differentiation is e raised to power f of x into derivative of f of x. What is f of x? E raised to power x minus y, which is equal to, on this side, what is derivative of log x? 1 by x, minus derivative of log y is 1 by y dy by dx. Now I am multiplying by, okay, before multiplying let us simplify it. Sorry, here the function is in the form of what, e raised to power f of x. So its differentiation is e raised to power f of x into derivative of f of x. What is f of x here? X minus y. So try to understand it. So here it is in the form of e raised to power f of x. So its differentiation is e raised to power f of x into derivative of f of x, where f of x is what, x minus y. So hope you all got it. So e raised to power x minus y, keep it as it is. Now we are finding its differentiation. Derivative of x is 1 and derivative of y is what, dy by dx. And on this side 1 by x minus 1 by y dy by dx, keep it as it is. Now I am multiplying by e raised to power x minus y to both the terms in this bracket. So e raised to power x minus y into 1 is e raised to power x minus y. E raised to power x minus y into minus dy by dx is e raised to power x minus y dy by dx. On this side 1 by x minus 1 by y dy by dx, keep it as it is. How many terms of differentiation are there? 2 terms of dy by dx are there. We are taking dy by dx common from these 2 terms. Let us see what we will get if we are taking dy by dx common from both the terms. So here this minus term will become what, plus, means 1 upon y, plus 1 upon y minus e raised to power x minus y. Just simply we have taken dy by dx common from both the term. Collect all the remaining term on this side, 1 by x, keep it as it is, and this plus term on this side will become minus e raised to power x minus y. Now I am taking cross multiplication here. Let us see what we will get. 1 minus y will get multiplied y into e raised to power x minus y divided by y into 1 will be equal to y. Just simply we have taken cross multiplication into dy upon dx, keep it as it is. On this side also, if we are taking cross multiplication, let us see what we will get. X into, means here 1 minus x into e raised to power x minus y, it's x into e raised to power x minus y divided by x. So now remaining part is just to find out the value of dy by dx, which implies that dy by dx will be equals to, now observe it very carefully, in the numerator 1 minus x into e raised to power x minus y, keep it as it is. Okay, I am keeping numerator as it is. And what is the denominator here? Denominator is x. In the denominator x, keep it as it is, isn't it? So we have written numerator also and this denominator also. Now our aim is to find out dy by dx. So using transformation we have to shift this term on the right hand side. तो y divided है, ये side में y divided है, तो इधर क्या होगा, multiply हो जाएगा. So y will get multiplied to it, isn't it? And and this term is multiplied to dy by dx, on this side it will get divided. Means if it will get divided, so in the denominator again what we are getting, already x is in the denominator, again what we are getting 1 minus y into e raised to power x minus y. Just simply ये term multiply थी, इधर आके क्या हो गए, divided हो गई. In this way, we have got the value of dy by dx, which is nothing but required differentiation of the given function. So in this way, we have completed all 9 examples from this exercise, from this question number 3rd. In the next video, we will discuss last question from this exercise. So if you think that these videos are helpful to you, please like the videos and share these videos with your friends also.